For an upcoming project, I needed to apply a lot of force in a very small area. And in my research, I learned about screw hydraulic rams, also known as grease screw rams. I don't know if I'm using the right term. If anyone knows the industry term for them, put it in the comments, because I could find very little information about them other than eBay listings. And I bought a couple to figure out how they worked. And it turns out it's very simple. You have a screw thread that mechanically pushes on a small piston in a small cylinder, displaces some fluid, comes out to a larger piston, and applies that same amount of pressure but over a larger area and gives you more force. The force amplification is simply the ratio of diameters. Now, for this little hydraulic nut splitter, it's only like 1.2 to 1, but the other benefit is you get to apply force around a corner because the fluid can go that way. Once I understood how they worked, I had a crazy idea for making an even more compact unit. And that would be this little guy here. Now, it's not that much more compact, but that's because it has another use case in mind. The top 30 millimeters is just heavy-duty bronze bushings and a sealing element at the bottom, because in the application intended, this will have an extreme bending moment on the shaft. Something will be trying to bend this shaft a lot, so it's actually supported for that length. But the hydraulic portion is only that much. Now, the idea that I had for how to make a much more compact unit is, as far as I can tell, novel, but not really ideal for mass production, etc., because it's fussy. The idea I had was, you don't need a tiny piston to displace fluid for you when there's a screw displacing the fluid. It's occupying some volume. The reason it's not really mass producible is that you then need to seal hydraulic pressures against the thread. Now, for my weird little application, for one-offs, I can make that work. I actually lapsed this thread to be perfectly consistent, and then used this to thermoform a polyethylene seal that I'm turned to be, I think the term is lip seal, but it has a 6mm lip, so there's lots of area for the hydraulic pressure to squeeze the thread. And it won't have a very long lifespan. It won't see thousands of hours of use, for example. But what this does allow you to do, basically, is having extremely compact, especially when the output shaft has a partial bore in it that allows the screw to enter into it. So the actual fluid chamber is tiny, but the force this is able to put out is still pretty ridiculous. I designed this, again, with just the materials I had on hand to sort of knock one up. If I was to source materials properly, it'd be able to be made much more compact, but allowing for hoop stresses and so forth, this is able to survive 40 megapascals or about 5,000 psi internally, with a factor of safety of 5 on all of the elements. But enough talking. Basic gist is, screw goes in, displaces fluid, pushes piston out. Complexity is in the seals. You would have a Tommy bar or something here, much like on that, or use a spanner, but... And you can see we've got a ludicrous mechanical advantage there. So that moved 5 millimeters approximately, and that moved 40 millimeters. So huge mechanical advantage. Again, the actual hydraulic part's only tiny, so if it weren't for the bushings that I need for my application, this thing could be quite small. But novel little idea.